Alright, ladies and gentlemen, I am here via video today to help you learn about using a mole bridge. So it's just the next step in our stoichiometry conversions. If you take a look, now that you know how to use mole ratios, which is what we've been practicing in class, now you're going to add it in with what you've learned in the previous unit from your mole map. So it's going to involve mole conversions today. So if you take a look at the mole bridge, we are going to start with a given quantity of a substance, and we're going to call that substance substance A. Depending on if that substance is given in moles or in a unit other than moles, I'm going to have to convert it to moles. So using a conversion from my mole map, I'm going to get that substance from, let's say, grams to moles, or liters of a gas to moles of that gas. After I do that conversion, and I have it in moles, then it's exactly like what we've been doing, which is using a mole ratio from my balanced equation to convert from moles of substance A to moles of substance B. Now, at times, this is where I get to stop. I get to stop at moles of substance B to answer the question. But other times I have to go through one more step, and that is again going back to my mole map and taking that moles of substance B and converting it one more time to, let's say, grams or liters or something along those lines. So, oops, didn't mean to do that. So erase that a little bit. So what we're going to do today is just going to go through a couple of example problems together, and then you're going to get to try some out. So if you take a look, here's our first example. So here's our glucose decomposing to form 2 moles of carbon dioxide and 2 moles of ethanol. And we want to know grams of glucose. That's the thing that we are trying to solve for. But we are given 87.1 grams of ethanol as our starting value. So just like we've done in the past, we are going to take our value given in the problem and write it down. So that's what I've got right there. So right now I've got a given quantity of substance A, and that is that 87.1 grams of ethanol. What I'm going to do next is take that 87.1 grams of ethanol, and I'm going to set up a fraction to convert that grams of ethanol to moles of ethanol. So you can see my grams would cancel, and I'll have moles in the numerator. After I do that, I'm going to add another fraction. You can choose to solve several times as you're going, or you can line it up in one big series of fractions. That's what I prefer, so that I'm not doing multiple roundings. So again, this is what we've already had. This right here is coming from my periodic table and from my mole map. This thing right here is coming from my balanced chemical equation. So 1 mole of glucose for every 2 moles of ethanol. The question is asking me to solve for grams of glucose, so I'm not quite done yet. So I am going to add on one more fraction, and that fraction is going from moles of glucose to grams of glucose. So this 180.1572 is the molar mass that I've added up from the periodic table. Here is all my work that I need to do to solve this problem. So you can see that I'm taking that value and multiplying it by a series of fractions. So take a moment right now and plug that into your calculator and see what you get. When I did that, I plugged it all into my calculator. My calculator gave me a value of 170 point a bunch of numbers. I rounded it to 3 significant figures to match the value given in the problem. So 170, you have to put the decimal in there to have the correct number of significant figures, and then grams of glucose. Take a moment and talk with your partner and make sure that you guys are on track right now. All right, after you've talked with your partner, let's take a look at example 2. So we've got a new balanced equation, and again, right now the balanced equations are given to us. So I've got 1 mole of nitrogen gas reacting with 3 moles of hydrogen gas, producing 2 moles of ammonia gas. In this problem, we are given 1.52 liters of nitrogen gas at STP, and it's asking us this time to solve for moles of ammonia. Just like we've always done in the past, I'm going to take the value given in the problem and I'm going to write it down. So 14.52 liters of nitrogen gas. Because that value is not in moles, I have to get it to moles, so I have to convert it using my mole map. And one thing that I know is that if I've got a gas and it's at STP, I know that 22.4 liters is equal to 1 mole. So right now this is me just converting from liters to moles. So I've gone up my mole bridge, essentially gone from a quantity of substance A to now moles of substance A, which in this case is nitrogen gas. Now I have to cross that mole bridge. In order to do that, I'm coming up with this fraction right here directly from my balanced equation. So you can see 2 moles of ammonia gas for every 1 mole of nitrogen gas. Now, here's where I get lucky. This question is asking me to solve for moles of nitrogen gas. So I actually don't have to do that downward slope off that mole bridge. I just have to convert to moles and then use a mole ratio. And this is actually all my work that I need to do for this problem. And now I just have to plug it into my calculator and solve. So take a moment and do that. Hopefully when you type it into your calculator and you round it to 4 significant figures to match the quantity given in the problem, you get 1.296 moles of ammonia. And that's exactly what we were asked to solve for. Hopefully so far so good, but again, take a moment and check in with your partner and make sure you guys are both on track. All right, so what I have organized for you next is those you-try problems with 2 balanced equations that are already given to you. And the answer is actually already given as well. But I want you to take a moment and work through this with your lab partner. But I'm going to annotate just like I always do. I'm going to use green this time just to spice it up. But I'm starting with 45.13 grams of water. And you might be asking yourself, but water is a product. Remember, in stoichiometry, it doesn't matter if I'm starting with a reactant or starting with a product. I'm just relating 2 things in the equation to one another. You'll notice again in this one, it's only asking me for moles. So think about your steps of your mole bridge. This is kind of an abbreviated problem. I want you to pause the video right now and take a moment and see if you can work this out before I show the work. Does your work look something like this? Did you take that value given in the problem and write it down? Did you convert from grams to moles? Did you multiply by a mole ratio from the balanced equation? And then did you take your answer and reduce the number of significant figures to match that in the problem? If you did that, give yourself a pat on the back. You are on the right track. If not, check in with the people sitting nearby and see if you can have them help you understand where you went wrong. We've got one more you-try problem. Again, I'm going to annotate just a little bit. 32.08 grams of hydrogen gas is given to me, and I need to solve for liters of gaseous ammonia. So notice this time it's not asking for you to solve in moles, it's asking you to solve in liters. That's a number that you can only get by using your mole map. Take a moment, pause the video, and see if you can work this out. And ask yourself, does your work look like this? Take the value given in the problem. You're converting it using your mole map, so grams to moles, getting a mole ratio from your balanced equation, 2 moles of ammonia for every 3 moles of hydrogen, and then 1 more mole conversion from your mole map to get from moles of ammonia gas to liters of ammonia gas at STP for a final answer with 4 significant figures of 237.7 moles of ammonia. Hopefully this video was helpful. It shouldn't be anything really new. It's just combining things that we learned during the last unit with mole ratios. Hopefully this went well and you can do a couple of practice problems to see if you really understand the material. Best of luck.